Hello everyone, welcome back to my channel. Today's video is a complete masterclass on FTIR, that is Fourier transform infrared spectroscopy, which is one of the most widely used instrument in pharmaceutical quality control laboratories. So in this session we will go beyond theory and look at practical and real world FTIR used in pharmaceutical QC lab. Friends, my YouTube channel name is Pharma Quality, so please view, like, comment and subscribe my channel. So now first we will understand what is FTIR. So FTIR stands for Fourier transform infrared spectroscopy, which is an analytical technique and used for first one is the qualitative identification of raw materials. So FTIR confirms raw material by matching the sample spectrum with the reference fingerprint, right? Second one is the functional group detection. So FTIR identifies functional groups through their unique absorption peaks, right? Third one is the polymer verification. So FTIR quickly verifies polymers by comparing their characteristic spectral patterns. Next is fingerprint analysis. So every compound has a unique FTIR fingerprints, which is used to confirm identity and purity, right? Next one is the confirmation of chemical structure. So FTIR validates chemical structure by showing peaks that match expected bond variation, right? So overall FTIR is based on how molecules absorb infrared light, that resulting spectrum becomes a unique fingerprints of the material. That's why FTIR is used heavily in pharmaceutical QC for raw material identification test, right? So now here we will understand how FTIR works. That is called Michelson interferometer, right? So here you can see in this diagram, the infrared light that is from light source is first collimated into a parallel beam. So it will reflect into this collimator mirror, and from this collimator mirror this beam hits the beam splitter, right? So this is the beam splitter, and when the this light get into this beam splitter, this divides into two paths. That light will divide it into two paths. So one beam goes to the fixed mirror, this one, and another one goes to the moving mirror, right? So both beams reflects back to the beam splitter. So here you can see this after the interference with the fixed mirror and moving mirror, this both light will move to the beam splitter, right? And where they recombine and create interference pattern, right? And this combined signal reaches to the detector here, and this detector records it as an interferogram. So later the instrument uses a Fourier transform to convert this interferogram into the final IR spectrum. So that's how the Michelson interferometer forms the core of every FTIR instrument. So now here we will discuss the FTIR instrument components. So in previous slide we have already discussed the how the FTIR instrument works. So here we will discuss through this diagram, right? So here first of all the source of light, the IR radiation from the source enters into the interferometers where it is modulated. That means it will split into the two beam, and from this modulated beam this passes through the sample, and the transmitted light reaches to the detector, right? So generally helium neon red light detector is used, right? So this detector records the signal as interferogram, right? So it will generate the interferogram like this, right? And then transmitted light reaches to the FFT computer, that is Fourier transform, to convert this interferogram into an IR spectrum. So in your software system you will have this IR spectrum which is showing the characteristic absorption peaks of the sample, right? So now here we will discuss about the sampling techniques, that is how many types of sampling used into the FTIR, right? So first one is the attenuated total reflectance, that is ATR, which is most common in quality control because it is quick, easy and required almost no sample preparation, right? This requires the minimum sample preparation. So with ATR, the sample is placed directly on the crystal, which eliminating the need for grinding or pellet making. So here, you don't need to prepare any additional pellet for this. This ATR is suitable for powder, liquid and semi-solids, which making it versatile for routine QC testing, right? And the type of crystal is used, generally it is diamond, right, based on the sample hardness and refractive index, right? So here you can see this picture, right? So this picture here, this assembly is called the ATR, and here you will have the option just a minor well type, so where you can put your sample, right? So this is the ATR assembly. Next one is the KBR pellets. So into the KBR pellets, it requires the fine grinding. So with the help of mortar and pestle, you can grind your sample, including the KBR. So KBR pellet is actually a moisture sensitive. So moisture is gaining throughout the sample preparation. And into the KBR pellet, you will have the option to get the very good resolution. And nowadays it is less preferred in modern labs. So we'll see the picture. So this is the KBR assembly to make it the pellet. So there will be the one pressure technique will be used to make a pellet, right? And after making the pellet, there will be the pellet holder where you will put your pellet, and this pellet holder will be placed into the FTIR unit, and the operation can be done to get your spectra, right? So now here we will discuss how to operate the FTIR. So first of all, instrument initialization, right? So you need to log in into the software system using your ID and password and turn on the FTIR instrument, right? Then select the project folder and select instrument type. So there will be the option for the instrument type, and then select the IR instrument, right? Then click on instrument option and select initialize option. Then instrument shall initialize, and option like background scan, sample scan, humidity, lamp and laser shall glow with the green light, right? So this is the I'm giving you example from the lab solution software, which is connected with the FTIR. So after initialization of instrument, upload respective parameter, that is saved method from the load parameter option, and select required method. So whatever the method you need as per your standard testing procedure, you need to be select that method, right? Then select the required report template and assign the file name. So here you can see this is the when you your instrument will be initialized, you can see this background scan and sample scan, and this humidity, lamp and laser will glow as a green light, right? So that means your instrument has been well connected and initialized, right? So once the instrument initialization has been done, you need to perform the background measurement, right? So for the background measurement, you need to click on the BKG scan option, and then message will appear as found background data from previous sessions and ask remove the marked data. Then you need to click on yes option, right? And when you click the yes option, there will be the message like prepare please prepare sample compartment for background scan, then remove anything if available from this sample compartment to perform the background measurement, and then click on OK. So you need to remove anything which is available into the inner side of the compartment of the FTIR. Then instrument starts scanning the background, and after completion of the specific scan, final background scan shall be appeared. So here you can see the picture. After the background scan, it is somewhat looks like this, right? So once you finish your background measurement, then sample measurement can be proceed, right? So after the preparation of sample, either you will use the direct sample with the help of ATR, or you will make the pellet to keep that pellet into the pellet holder and put it into the FTIR instrument, right? So please place that in sample into the compartment, and then there will be the option for the sample scan. So you need to click on the sample scan option and the instrument start scanning this sample, and after completion of this specific scan, final sample spectrum shall be appeared, right? So here you can see the spectra, which is a one of the paracetamol molecule spectra, right? So this is the spectra for this sample, right? So once you finish your sample measurement, then you need to perform the data processing for the peak pick option, right? So to perform the data processing for peak pick, you need to be select the drop down parameter of manipulation, right? And then from there manipulation option, you need to select the peak pick option, right? Then specify the threshold or noise based on the requirement and press cal key, which is followed by OK option to get the peak table, right? And then go to the database and select the respective data file and print the report. So here you can see once you will perform your peak pick, so your spectra will capture all the wave numbers as per the fingerprints, right? So now here we will discuss the data processing for purity calculation, right? So for purity calculation, open the standard and sample, that is two data you need to be select, right? Then click on tools and select the print preferences. So there will be the option to select the report template file of purity and click on attach followed by the OK, right? Then click on manipulation tab and select the purity option, right? Then purity calculation window shall be open, and then you need to select the first data, that is for the standard, and right click on the this first data and select the option send to source, and then further you need to select the second data, that is for the sample, and then right click on it and select the send to reference option, right? After that both the data shall be overlapped, then click on calculation option, right? So purity calculation shall be done, then click on OK to submit the purity calculation data, right? And then you can print your report. To view the overlapped spectrum, open the required spectrum and then select the window option at the top menu followed by the join all parameter. So once you will click on this, your standard and sample spectra will combine together and it will looks like this, right? And then you can e-sign your report and submit this report for the review and approval process. So this is overall the operation and processing of the data, right? So this is overall the basics of the FTIR and its operation. So into the next video, we'll discuss about the calibration of the FTIR. Thank you.